Our next two problems are going to focus on triangles. We'll start with an area problem and then we'll wrap it up with a Pythagorean theorem problem. So we're given the area of a triangle. It says the area is 87, the base is 9x plus 4, and the height is 2x minus 9. And we're supposed to find the value of x. So as always, we want to begin by setting up our area formula, which is 1/2 base times height. We're going to substitute in our information. And then there's so many ways to do this. We can FOIL this problem out and then distribute 1/2 to everything. We can multiply both sides by 2 and eliminate the fraction altogether. So that's actually the approach I took. I doubled both sides so that there was no fraction in the problem, and then I FOILed the right side out. So however you want to do it, that's completely up to you. And then we're just going to clean it up a little bit. And while we're cleaning it up, we're going to go ahead and move the 174 to the other side. So I get 18x squared minus 73x minus 210. So these are really big numbers, and I did look to see if I could find a GCF in these numbers, but unfortunately there's nothing that goes into all three of them. So we're going to have to make our x. And if we multiply 18 and 210, we get 3780. So we need to find factors of 3780 that make 73. Now, the reason that they're giving us this hint is because this is such a big number, it would take a really long time for you to find those factors. So they're telling you, hey, 35 and 108 give you 3780, and coincidentally, they happen to be 73 spaces apart from each other. So you're supposed to go ahead and figure out which combination would make negative 73, which would obviously be negative 108 and 35. And now that we have our numbers, we'll go ahead and rewrite our polynomial. We'll group them up, and we'll factor out the GCF from each group, which would be 18x and 35. And then we'll regroup those together. And then, like all of our factoring problems, we want to set the first set equal to 0, and then the second set equal to 0, and solve for both. So we'll get the answers negative 35 over 18 and 6. And again, because it's a geometry problem, you would want to substitute these back in so that you make sure your dimensions are positive. If we put negative 35/18 in for x, we're going to get a negative minus 9, which is going to be a negative. And we can't have negative height, so 6 is the only answer that makes logical sense in this problem. In our next equation, we're giving 3 sides of a triangle all in terms of p's. So we want to go ahead and use Pythagorean theorem, which is a squared plus b squared equals c squared. And that's something we would have learned back in geometry. So this is our initial setup for the problem. You want to make sure that your c, or your hypotenuse side, is in the correct place. The a and b can be switched, but the c has to be in the same place. Now, what a lot of people do wrong, and this is really what costs a lot of points whenever you're taking a quiz a lot of times, is kids want to distribute this squared into the parentheses, which is a major, major PEMDAS violation. We can't distribute a squared into a group where there's a plus or a minus. The only way we can handle that is by FOILing it out. So we'd have to write this twice and FOIL it out to get the following trinomial. Then we'd have to do the same thing with the other two trinomials, which will give us this set and then this set. So that's the proper way to do it so that no laws of PEMDAS are violated. And then we just want to clean it up a bit. So I'm going to consolidate this right side down. I can consolidate my p squared terms into 40, my p terms into negative 196, and then 25 and 16 into 241. And because I'm going to need to factor, we do want one side to be 0. So we'll move the 16p squared over here to make 24. We'll move the 40 over here to make 156. And we'll move the 25. Now there is a GCF that goes into, there's something that goes into 24, 156, and 216. If you weren't sure, you could start with 2. You could definitely divide everything by 2 as they're all even numbers. And then see where you go from there. If you can divide by 2 again, great, go ahead and do it. I happen to know that 12 goes into all three of these, so I went through and divided all of these by 12, and now my numbers are a lot more simple to work with. So I'm going to go ahead and make my x and put 2 times 18 in the top, my negative 13 in the bottom. It's not too hard to find the numbers that make that puzzle work. Once we found that negative 9 and negative 4, we're going to go ahead and rewrite our polynomial, group it up, and we want to make sure that we have that negative in with the 4 and that we separate these with a plus sign. And then we're going to factor out the GCF from each group, which for the first group would be P, and the second group would be negative 2, so that these parentheses match. I'm going to regroup it, and if we set each of these equal to 0, we're going to get 9 halves and 2 as our answers. Now, a lot of kids go ahead and circle that thinking, oh, I got a positive number, that's great. A positive number for x does not necessarily mean you get a positive side length. The only way you're going to know if these answers are safe is if you plug each one in to each side and make sure that it works out. So if we do 2 times 9 halves and we subtract 4, that's going to be a positive number. Same thing with 6 times 9 halves and 4 times 9 halves. So we'll be okay if we do that. But if we put 2 in for P, 2 times 2 would get you 4, and 4 minus 4 is 0. So you're telling me that the length of this side is 0, and that's not possible. So we have to throw out 2 as an answer and just go with the 9 halves.